One of the reasons I've chosen this little gem, not only because it's budget friendly, but also it's a very versatile piece of electronics. It does contain inverter for 2 motors, also it has DC to DC converter and a buck boost converter. In this video I'm going to talk about DC to DC converter. Why do we actually need one? Well, it's used in an electric car instead of an alternator. Why do we need an alternator, you may ask? Well, it's because we need to charge the 12 volts battery, which is needed to power low voltage electronics in the car. In the internal combustion engine, car alternator is a generator which is driven by the motor and charges the 12 volts battery when the car moves. In an electric car, our energy is stored in the battery, so it is more efficient to use the DC to DC converter to charge the low voltage battery directly rather than using motion of the motor. So the DC to DC converter in this case would have to convert high voltage from the big battery and step it down to a few hundred volts to about 14 volts. Let's see if I can get DC to DC converter to work in the Prius inverter using open inverter board. There is a number of ways of enabling DC to DC converter. First thing we will need to do is to connect this DC to DC on-off jumper, so which basically links the 12 volts and this signal together, and this will apply the 12 volts to this pin number 7, and also we have DC to DC sense signal which will require 12 volts connection as well, and those two signals here would be connected to Atmega chip running Arduino, and basically those two connected to pin 13 and 14. So those pins, pin 13 and 14, they correspond to pin 9 and 10 on the Arduino platform. So the way that DC to DC converter works is it will start a little over 100 volts. If the voltage exceeds 240 volts, it will effectively shut down and will not allow to work at higher voltage. But basically one of the members of Open Inverter Forum worked out how to modify the resistors on the board for the DC to DC converter and allow it to work at higher voltage up to 400 volts. Because I'm using unmodified resistors at this stage, I'm going to be using this sketch to run the buck boost to step down the voltage on the DC to DC range. As I will need to change the resistors for the DC to DC converter, I will need to get to the bottom of the inverter itself, and I will have to basically take off this bottom panel. So I have started doing it when I was opening an inverter, but I had a bit of trouble opening it, and now I think it's a good time to actually do it to gain access to the DC to DC converter. First I want to use a carpet knife just to break off the seal a little bit. It's quite tough in here. I'm just trying to free up. Okay, this seems to be working on this side. Okay, let's try to do the other side in a similar way. So rather than forcing it, I'm just sliding in the spatula and hopefully breaking the seal. Okay, now using slightly different method. It seems to be working, but not easily. Not going too far, not to damage the inside of the inverter. I went all the way around the inverter and carefully step by step freeing up the sealant by knocking on the spatula with a mallet. I save you the joy of watching me doing this, and I will jump straight to the end when I'm about to open the inverter. Hey! Looks like it's opened. Let's have a look what we have here. So this is our inductor, which is part of the buck boost module, and this is DC to DC converter. So this is where high voltage comes in here, and this is the cable that comes from the open inverter board. And I believe that if we put 12 volts on 2 of these wires, and then we should be able to get DC to DC converter working. However, I do have a bad news. While I was opening the cover, I think I damaged some of the cables. If I zoom in here, you can see this is where I unfortunately inflicted some damage, which I'm really disappointed, because I was thinking about the fact that I should be careful not to slide, the spatula too far. But actually, this is the only place where I should not have done it, and it looks like that's a place where I did it. Yeah, I'm so pissed off with myself, to be honest. Well, a bit of a setback, but with these things, it's always something goes wrong. So yeah, back to the drawing board and try to repair the connector and look at the DC to DC converter board a bit further. I needed to separate each strand of the ribbon cable to be able to desolder each individual connectors. Basically, it turned out that the material that looked like paper turned out to be rather tough, and it was quite hard to cut it. I had to use my cutters in the end to be able to separate each wire. Once all the wires were separated, I was able to start desoldering, starting from the top board and finishing at the bottom board. The most difficult to desolder turned out to be a bottom part, especially one of the tracks that was connected to the ground. Clearly Toyota using lead-free solder, and the fact that this wire was connected to the ground polygon didn't help with desoldering. As I had no access to the bottom of the board, I had to clean up the hole before I can insert the wire. So after the wire was inserted, then I was able to solder it in place at the bottom board first, and then it was much easier to solder at the top. I only show you one wire. As you can see, it's rather tedious process, and it's really hard to solder under the camera. And finally I was able to assemble the board back, a little mistake that cost me about 3 hours of work. Nevertheless, we have board assembled and ready to continue. We're currently connecting at this point. This is our plus and this is our minus. So at the same time we could see that the high voltage delivered to the DC to DC converter is at this point and in this point, which is basically this connection. So I think if we connect this point here to our plus, so effectively we will be able to supply the high voltage to the DC to DC converter, and minus is exactly the same, it's common. Thanks for coming on this little adventure with me. I will continue my experiment in the next video, and I'm hoping to get DC to DC converter working. I would love to know if you had experienced similar setback where you had to go and repair the damage you inflicted yourself. Leave a comment below and share, and I will see you in the next video.